Hey guys, Jay here with Word of Advice TV, and in this video I want to talk about low voltage shorts. So if you come to a unit, or maybe it's at your house, and the 3 amp fuse is blown, you replace the fuse and it just blows again, that means you have a low voltage short somewhere, and that's what this video is going to be all about, to track down that short, to see what is causing this fuse to blow. Usually there will be a little burnt mark in the middle of the fuse where it blew. Some furnaces will not have a fuse. They'll have a little 3 amp breaker instead. I believe it was Lennox that was doing that for a while. I think they still do. That's where I got this little breaker. I pulled off an extra that I didn't need. And then some furnaces like mine, for example, they don't have a 3 amp fuse at all. So I spliced one in. So I'll show you how to do that as well. And the purpose of the 3 amp fuse is mainly to protect the wires, because when there's too much current going through the wires, they start melting. So for example, this little alligator jumper that I have, I've seen this before where there's a short and I jumper a thermostat, for example. I've seen this little jumper wire become a snake, you know. You turn on the power to the furnace and this thing just starts to coil up and twist, and you see the insulation melting on it. So the purpose of the 3 amp fuse is to stop that. If there's overcurrent, too much current, that fuse blows and prevents anything from melting. So primarily there for the wires, but it ends up protecting the components as well. If you don't have a 3 amp fuse inside of your furnace or your air handler, you definitely should splice one in, because if there's no fuse and there's a low voltage short, then your control board, your transformer, and your thermostat are probably all going to get taken out if you do get a short somewhere. There's 2 ways that you can try to track down a short. One way you will definitely need a meter for, and that's to check resistance. When checking resistance, the power should be off, and whatever you're checking, the wires that you're checking, the wires should be disconnected. The other way is to leave the power on, and you can really narrow it down without a meter, but in order to pinpoint, you probably will need a meter, but you could probably get away without one too. But I'll show you how all that works. So let's begin. I'll just take my furnace apart quick. I already have the power off. I have the power switch off to my furnace for now. So here's my control board. I'll just put some more light here. And because I have so much wires here and I don't really want to disconnect them, I have 2 more control board examples right here as well that we will touch on instead of this one, so I don't have to take mine out. But remember how I mentioned that my control board did not have a low voltage fuse or a 3 amp fuse? I have a 5 amp fuse on mine actually. But the way I put this one in is very simple. If you look at your transformer, in my case my transformer is right here. The transformer will have a primary side, which is 120 volts, and a secondary side, which is 24 volts. Primary side is always going to be, not always, but almost always, primary side is going to be a white wire and a black wire. That's your 120 volts. 120 volt hot, and this white one is the neutral. And the other ones, typically red and blue, is your 24 volts. Usually the red is the hot, and then the blue is the secondary common. And if you're not sure which wires are which, you can also look on the transformer itself. A lot of times it'll be labeled which one is the common, which one is the hot, or you can trace the wires, see where they go, try to figure it out that way. Or you can look at the wiring diagram, which is from your furnace, usually on the back of a furnace door, and try to figure out which wires are which using the wiring diagram. And I don't want to spend too much time on this, but basically on the wiring diagram, if you look at the legend, it says TR and TH. TR is the common side, and TH is the hot side. Here's our transformer. That's the symbol for the transformer. You got a blue wire coming out of it, and you got a red wire coming out of it. And if you trace them down, TH right here is the red wire, and TR is our blue wire. So right here, TH is our hot side, and that is the red wire. And even though I have a symbol for a 5 amp fuse right here, my control board actually did not have this 5 amp fuse. I had to splice it in myself. So if we look back on our control board, here's that blue and red wire, and they go into this big Molex plug right here. A bunch of wires, and this Molex plug is signified right here. There's the TR, which is the blue wire right here. And there's TH, which is the red wire right here. I won't go into that either. All control boards are different, so I don't want to specifically focus on that one. But anyways, the two wires coming from the secondary side of the transformer. The red one is my hot. All I did is I cut this red wire in half and I put two female connectors on it. So let's just unplug this to show you what that would look like. So literally, this used to be one piece of wire. I cut it in half and crimped on these connectors. And then the fuse has the male spade connectors. You just plug it right in. And now you have a fuse in line with your low voltage. So if something goes wrong, instead of everything going out, your transformer, your board, your thermostat, only the fuse blows. So that's one style where the board doesn't have a fuse at all, or maybe it does have a fuse, but it's kind of dangling like this. Sometimes it's fastened to something. Mine is just kind of hanging out in the middle of all my wires. Another style is this 3 amp little circuit breaker. I believe Lense is the one that uses this. And generally the breaker will not be on the control board itself. It'll be mounted to the bracket that holds the control board. So for example, like right here somewhere, by the transformer, you'll see a little breaker. There'll typically be a little hole for it. And if it's tripped, the breaker will pop out. You can press on it to reset it, and it resets. But it works the same as a fuse, except that one's resettable, which is kind of nice, the 3 amp breaker. So I kind of like the 3 amp breaker more. And the last style, which is the most common actually, is where the 3 amp fuse is on the control board itself. So if we look at this board, for example, the spot for the fuse is right here. So if you come down to your furnace, you take the doors off, you just kind of have to take a close look at the board and look for a fuse like this. A lot of times it'll be purple, or this color right here, the violet. It can be some other color, but generally it'll be that color, maybe yellow or orange. And right here, see how it says secondary? That's where the secondary hot wire from the transformer would plug in. And so basically right here and right here, this is my fuse, this is the secondary hot side. If we look at the underside of the control board, that circuit is connected. The hot side of the transformer and one side of the fuse. So that would be the same as a splice in the wire like this. Okay, so let's get into how to chase down a short. Let's start with the power on. I'll flip my furnace switch back on. And there's a little light right there. Most control boards will have an LED light or a troubleshooting light. That should be on if the fuse is not tripped. If the power is on and the light is off, a lot of times that means your little fuse is tripped. Okay, so with the power on, the first thing I like to check is to make sure that the secondary side of the transformer is actually outputting the correct voltage, which should be somewhere between 24 to 29 volts. And when you take the bottom door off of your furnace, or your air handler, of course there's going to be a door switch like this, and you have to tape the door switch with either some electrical tape, put a strong magnet on it, put some sheet metal tape on it. But basically this door switch needs to be closed, otherwise all the power is shut off to the furnace. So once you have the door switch closed, the power is on, you have your meter set to voltage. I like to just verify and make sure that I have 24 volts. So I would put 1 meter lead on one side and 1 meter lead on the other. And if we look at my meter, I have around 28 volts. So we do have the proper voltage going in. And at the moment, the thermostat is set to off, so the control board is just in standby mode. So if I come to a furnace and the 3 amp fuse is blown, or the 5 amp fuse is blown, the first thing I do, if I'm going to check it with the power on, I first turn the power off to the furnace. I unplug the current fuse from the control board or from the wires that it's connected to, and I put in a 3 amp breaker like I have right here. This is what I typically use. This is just a 3 amp breaker with 2 wires connected to it. One side has a female connector, the other side has a male connector. So I have a 3 amp breaker like this that I use instead of a fuse, or they have special tools for exactly this purpose. For tracking down a short, they have a little mini popper that's also a 3 amp breaker, and they have a short pro tool that you could get that has a little light on it. If the light goes out, that means there's a short. But this is what I use. It's a little 3 amp breaker. So instead of the fuse, Or, of course, you could just get a box of fuses, get like 10 of them, and every time it blows, just keep replacing it. But I like to use this because it's resettable. And then, for example, you would plug in your 3 amp breaker or your mini popper or whatever you're using in place of that fuse. So now if there's a short somewhere, if I'm jumpering things and I'm checking stuff, this breaker will trip and I can just manually reset it instead of having to replace a fuse every time it blows. So here's a typical air conditioner and furnace setup. This is not a heat pump, this is just straight AC. This is what it would look like. This is basically the wires coming from your thermostat. Typically it'll be 5 wires. They go into this thermostat strip on the control board, and then you have another 2 wires that go out to your air conditioner outside. And those 2 wires that go out to the air conditioner ultimately end up powering up the contactor coil, which is inside of the condenser unit. And once the thermostat calls for cooling, this plunger pulls in and allows the power to go through. And I won't go into basic thermostat wiring in this video because I have another video where I describe that in detail. If you want to know more about wiring, just check out that video. To begin with, it's good to rule out the thermostat. So if you go upstairs or wherever your thermostat is and take the thermostat off the wall, then take all the wires that go to that thermostat. You could take a picture of them or label them and then pull them all out so they're just open like this. And I have another video where I talk about how to bypass a thermostat at the control board and at the thermostat itself. So I won't talk about too much details on that either. But your red is going to be your power wire, the 24 volts coming from your control board. And yellow is typically cooling, W is heating, and G is fan. So after you replace your little 3 amp fuse, or maybe you put in your little circuit breaker, like this, you disconnect all the thermostat wires and then you bypass the thermostat by hooking up one jumper cable to R, which is power, and the other one to heat. And if your furnace is off, at that point you go downstairs and you turn the furnace back on. If the air conditioner comes on and does not blow the fuse, then you know that the thermostat is the problem. That's what's causing the fuse to blow. If you're checking heating, if it's the furnace season, you would jumper R to W, which would bypass the thermostat. If your furnace comes on without blowing the fuse, then you know that the thermostat is the problem. And if you jumper R to G, that will turn on the blower fan inside of your furnace. Once again, if this turns on no problem and doesn't blow the fuse, then you know that once again there's no problem with the G wire and the thermostat is internally defective, and that's what's causing the short. So that's how you rule out the thermostat to make sure that it's not the thermostat that's causing the fuse to blow. And usually it'll be pretty obvious. I mean, if it's the AC season, chances are something's wrong with the AC side of it. And if it's the heating season, then chances are something will be wrong with the heating or the furnace side of things. It's pretty rare that the fan is the cause of the problem. So in summary, this test is only to rule out the thermostat. Actually, you don't even have to take the wires off of the thermostat. So if you just take the face of the thermostat off, you can just jumper it right away without taking the wires out. If you have little magnetic jumpers like this, that works even better. They just stick right to the screws that hold down the thermostat wires. So for example, if you turn your thermostat to heating and the fuse blows, turn the thermostat off, go downstairs, replace the fuse, come back to the thermostat, take the thermostat face off the wall, and then you will jumper R to W, which is the same thing as setting your thermostat to heat. And with the face of the thermostat off, the furnace turns on without blowing the fuse, then you know that the thermostat is bad. If you do it this way and the fuse blows anyway, then you know the thermostat has nothing to do with it, the thermostat's fine, something's wrong with the 24 volt side of the heating circuit, and that's tripping the fuse. After you ruled out the thermostat, next thing I do is take off all the wires from the control board thermostat strip. You of course want to label them or take a picture if you're not sure where each wire goes. And then take all the wires off. And while you're doing this, you want to have the furnace power off because if you touch the red wire to pretty much any of these, it'll short out and blow the fuse if you have a fuse in there. So after you have these wires taken out, kind of just spread them out so they're not touching each other and they're not touching anything metal. After you have all the wires off, I would test it one more time. So I would turn the power on with all the wires disconnected and see if the fuse blows. If the fuse does blow, that might mean that your control board is internally shorted somewhere and you might need to replace the control board. I don't see that very often at all, that the control board is the cause of the fuse blowing. And after you verified that the fuse does not blow with all the wires off of it, you can turn the power back off. You can stick the red wire, which is power, into R, tighten it down, and then I like to put in all the components one at a time and see if they blow the fuse. So I would put in G, which is fan, turn on the furnace, make sure it doesn't blow. I would put in W, which is heat, turn on the furnace, make sure it doesn't blow. Put in Y, which is cooling, turn the furnace back on, see if it blows. And then C is common. That one we could have even left in. This one's not a hot wire, so this shouldn't ever cause any kind of shorts, the common wire, unless it's touching one of the hot legs. So all of this you'd be doing with the thermostat setting set to off and the fan on automatic. And the purpose of this test with everything off is to see if these wires going through your wall and then the wires going outside is to make sure that none of these wires are internally shorted. So if the insulation is off of the wire, for example, if the common wire, if the insulation somewhere inside of your walls is gone and it's touching your red wire, which is power, which is also bare. I mean, the only scenario I can think of most of the time is if somebody was, I don't know, driving a nail through the wall and the nail went through the wire. And if somehow these two shorted to each other, that would blow the fuse. So this test right here with the thermostat off, pulling all the wires off and then putting them on one at a time, is to check and make sure that none of these wires have missing insulation and are touching each other inside of your walls. After you got your thermostat wires hooked up, you can go ahead and hook up your air conditioning wires. And this should not trip the fuse because really the only time there should be power going to this Y wire is if the thermostat is calling for cooling, but your thermostat is off. But these as well, you can put on one at a time just to make sure nothing trips. Put all your wires back in and you can screw them all down. So after you verify that you're getting about 24 volts from the transformer, you know your thermostat's not the one causing the problem. None of these are blowing the fuse with the power off on the thermostat, just set to off. You can proceed to the next step. And for this step, you can either go up to your thermostat and for each thing, just turn it on to heat, then try cooling, then try fan. But if you don't want to run back and forth, you can just jumper the thermostat at the control board. So of course, R is our power. I can jumper R to G, which is our blower fan. And with the furnace power on, that should turn my blower motor on. So for example, let's try that on my furnace right now and see if the blower motor will come on. So I turned the power switch back on. And when you're jumpering, you actually want the power switch off. So let's just turn the power switch back off. I'll jumper R to G, and that should turn on my blower fan. There it goes. Turn the power back off. And then if I would jumper R to Y, that would turn my air conditioning on, and R to W would turn my furnace on. So I would check these one at a time to see which one of these will blow the fuse. So if you check it R to G, the fuse doesn't blow or the breaker doesn't trip, you can move on to the next one. The next one is R to W. If you jumper R to W, the breaker doesn't trip either. And then you jumper R to Y, and all of a sudden, your little 3 amp circuit breaker pops. In that case, you know that the cooling part of it is what's causing the 3 amp fuse to trip. So if the fuse blows when you have power going from R to Y, that means that your problem is going to be either the wire itself going outside to your condenser unit, or something inside of the condenser unit. Maybe there's bare wires, mice chewed it up, or the contactor coil could be bad, and that's what's causing it to short out. So if your fuse is blowing when your air conditioner turns on, I would go outside, and before I do anything else, I would visually inspect the wire. Make sure there's no breaks in it, there's no bare spots where it's touching anything metal. Then I would also open up the electrical section, make sure that the wires are not broken or chewed or anything like that inside of the unit itself as well. And if you don't see anything obvious, the first thing I do is I like to narrow out the possibility that there's a short inside of the wire itself, where the white and red wire are somehow touching each other, maybe inside of your walls somewhere. I like to rule out that possibility, and it's very simple to do that. All you have to do is disconnect the 2 wires coming from your transformer, or basically from your control board inside of the furnace, from the 2 wires that go to your contactor coil. With those 2 wires disconnected and not touching anything, I would turn the power back on, turn your air conditioner on, or just jumper it at the control board, R to Y. If the fuse does not blow with everything disconnected, that means that the wire is good. If the fuse, or if the 3 amp breaker trips with the wires disconnected, then you know that the problem actually lies in the wire itself that runs from your control board to the outside unit. So you either have to try to find where it's shorting out, or you'll just have to simply replace this whole piece of wire. And a lot of units are wired very simply, where the 2 wires coming from the control board will go straight to the contactor coil. But there are times where only one side, like a white for example, will go to the contactor coil. And by the way, if you're wondering if it matters if the red wire goes to this side of the contactor coil or this side, it does not matter. These 2 wires, they can go either way. So let's say one wire goes into the contactor coil, but if you have a bunch of safety switches, like the low pressure switch, the high pressure switch, and maybe like a fan delay board or something, then this wire, the red wire, it'll go into a different loop. So for example, this wire will go into a wire nut that goes into the low pressure switch, then comes out of there, goes into the high pressure switch, comes out of there, goes into the control board, and only from there it comes back and goes into the contactor coil. So if your fuse is not blowing with the wires disconnected, but with them connected it is, that could mean that your contactor coil is bad, or one of those components, one of those safety features, is causing the short. If you do have all those extra components wired in series with your contactor coil, the easiest way is to just disconnect the wires from them and just ohm those components, like the low pressure switch, high pressure switch, the control board, ohm them to ground and make sure that they have no resistance between ground. If they do, that means they're shorted out. And you would do that similarly how you would ohm out a contactor coil. So for example, here we have 2 contactor coils, right? One's a 2-pole contactor. This one right here, it has a cover over the 2 poles. This is a single pole contactor. It just has the 1 plunger. And the coil is right here. Sometimes this coil gets shorted together, and if it gets to that point, that will blow your 3 amp fuse. So if we check our 2 contactors, a normal resistance on a contactor is about 10 to 20 ohms. So with the wires disconnected, you'd put 1 lead on one side and 1 lead on the other. And we're getting a read of 17.8 ohms. So this contactor coil is good. If we measure our other one, we're getting around 10 ohms on this one. So this contactor coil is good as well. And I've noticed from experience that anything under 8 ohms may start to trip that fuse. So it should be above 8 ohms. And if you're seeing 0 ohms, that means this contactor coil is completely shorted together, and that will blow your fuse every time. And to check if a component is shorted to ground, like let's say if this contactor is shorted to ground, or maybe the compressor delay board inside of the condenser unit, all you would do is disconnect power, disconnect wires, and then if I go from one side of the contactor coil, and then let's say to the screw that holds this contactor to the housing of the unit, if I put the other lead on the screw, you should be reading OL, open line, like that. If you have resistance, that means that that component is shorted to ground. Then you can go to the other side of the contactor coil, check it to ground as well. You should have OL there as well. And that's how you would check the other components as well. And if your 3 amp fuse is blowing when you jumper R to W, or when your furnace is on, that means that chances are one of your safety switches is shorted to ground. So maybe it's a pressure switch or a high limit switch, a flame rollout switch. The first thing I would do is just visually inspect all the wires going to your safety switches. Make sure that there's no bare spots, there's no kink spots. Maybe some wire is pinched in between two metals, or maybe over the years from the vibration, if a wire was touching the metal part of the furnace, or especially where it's getting hot, maybe that wire rubbed a hole in the insulation and it's starting to short out. So look for any visual damages. If you don't find any, at that point you would need a meter. You can set it to continuity or resistance. And with the power off to the furnace, you would disconnect the wires and just check from each terminal to ground, which is basically any screw that screws into the furnace. And you should have OL from every switch to ground. If you have continuity from any of the switches to ground, then you know that that switch is bad and is shorting to ground. I remember this one furnace that kept tripping my 3 amp fuse, and for a long time I couldn't find what was tripping it. Finally I narrowed it down to the high limit switch right there. And if I went from one terminal to ground with the wires disconnected, I actually had continuity from this switch to ground. So I took that switch out, and the two prongs that hold the high limit switch inside of the heat exchanger, the two prongs going in there, they were actually, one of them was touching the walls of the cabinet of the furnace, and it was shorting out. So right when the furnace would call for heating, that thing would blow that 3 amp fuse right away. Alright, and lastly I just want to go over ohms, how to try to track down a short using the ohm or checking for resistance. As I mentioned previously, when you're measuring resistance, you want to have the power off. If you have the power on and you try to check resistance with your leads, chances are you're going to burn your meter out and you'll need a new meter. So you want to have the power off and the wires that you're checking disconnected. So for example, let's say this was my thermostat wires going to my control board. I would want to pull all of them off and just leave the common wires on. So the common coming from the condenser unit and the common going to your thermostat, both of those would stay on and the rest of the wires would come off. And then I'll do this example on my actual control board. So I pulled off a couple thermostat wires from my control board. I'll put 1 meter lead on my common with the common wires connected to it. And with the other meter lead, I'll just check my other wire. For example, the G, which is fan. So G to fan should be OL, open line. There should be no continuity, otherwise that'll be a direct short. So my fan wire is not shorted out. And for example, let's just check Y as well, the yellow wire. That one is OL as well. So that one's not shorted out. And let's say one of them was shorted to ground. So I'll go ahead and simulate a wire shorted to ground by touching it to the metal here. So my fan wire is now touching metal. And if I check it now, I'm getting 0.5, 0.4 ohms. Many times it'll just be 0.0. If you're getting resistance, everything should be OL. If you're getting resistance between common and one of the hot legs, one of the hot thermostat wires, that means that wire is shorted to ground. Well guys, and that's how you check which wire is shorting out using the resistance reading on your meter. I prefer to use the power method, which I spent more time on. And that's actually all I had for this video, how to track down a low voltage short. I hope you found this video useful. If you have any other comments or suggestions, especially if you have experience dealing with low voltage shorts yourself, It would be awesome if you can share your experience with us in the comments below. Thank you so much for watching this video. Don't forget to mash that like button on the way out, and we'll see you next time. And if you're still here and not in the comment section below, let me show you one more little tip. So let's say this won't involve a blowing fuse most of the time. Let's say that you suspect that you have a broken wire inside of your walls, a broken thermostat wire somewhere inside of your walls, and you really have no good way of visually checking it. An easy way to check which wire is broken is to go down to your furnace, the furnace control board, pull off all the wires from your thermostat as well, and then at your thermostat, take any two wires, especially the ones you're suspecting. Let's say your heat is not turning on, which would be the white. Go ahead and wire nut the white wire along with G, or the green wire, together. So with these two wires wired together, this is essentially just one piece of wire now. And if you go down to your control board with the wires disconnected, if you set your meter to continuity and check green to white, you should have continuity. We hear an audible beep, so that means we do have continuity. If there was no beep, that means that either the green wire or the white wire has a break in it. To narrow it down, you can just wire nut green and red together, check it, and then wire nut white and red together and check it. And whichever one does not do a beep, that's the wire that's broken. So hopefully this will help you out someday.